using the fact that if I have an expression of a squared minus x squared anywhere in my integral, doesn't have to be numerator or denominator, the substitution I use is x equal a sine theta. Okay, so since I have 9 squared minus x squared, I'm going to use x equals 3 sine theta d theta. 3 sine theta. So make sure you don't make the common mistake. The common mistake is to forget to compute the dx, which is 3 cosine theta d theta, and to replace dx with this big ugly thing. So 3 cosine of theta d theta is the dx, right? And then here I've got x being cubed, and so that means I have 3 sine theta cubed. And then I've got this radical. So inside the radical, oops, I'm going to use a different color here. So inside the radical here, you know you're going to have an identity. So 9 minus, and everywhere there's an x, I'm putting this in. So I'd have 9 sine squared theta. Okay, so let's go a little slower here. So here I would get a 3 cubed, and I'll just pull it outside. Doesn't matter what the number is, sine cubed. Here I would say root 9, root 1 minus sine squared theta, because you're always looking for an identity to happen inside the radical, because this method gets rid of the radicals. Gets rid of the radical and by an identity. And then I'm just going to carry this 3 cosine theta along. Okay, here we go. So this 3, and this 3. So I get 3 cubed times another 9. So I get 3 to the 5th power. Just going to leave it there. Sine cubed theta. That's this one. This cosine comes down. Cosine theta d theta, and let's think about what this is. Inside this radical, I've got a cosine squared. So I take the square root of the cosine squared, and that gives me a cosine. So I get cosine times cosine, so that's cosine squared theta d theta. All right, what do I do with that? Back to section 2. In section 2, we learned that if you have sines and cosines, and they're not both even powers, that you want to peel off to make a good du. So I'm going to peel off one of the sines. So there's my du. So du is equal to sine of theta d theta. So u will be, oh, this is the negative issue, right? I don't want to let u equal negative cosine. So I say, okay, u is cosine, du is negative sine, and I put the negative here. So if you look back at your section 2 notes, I call this the negative issue. This is the easiest way not to make a mistake. All right, here we go. I want to make this u substitution work. So this will be good, this will be good. Oh, I need to work on this. So I'm going to carry this 3 to the 5th. What can I do with sine squared so that cosine will work? I can replace that with 1 minus cosine squared. And then this is carrying along sine theta d theta. So you want to make sure you're going all thetas to all u's, right? This is the u substitution you're using. So I get 3 to the 5th, 1 minus u squared du. Oh, but it's a negative du, right? So I'll pull that negative out in the front, and then I'll multiply. So that negative comes out here. Then I'll multiply, so I get u squared minus u to the 4th du. Now you're ready to take the antiderivative. So I get 1/3 u cubed minus 1/5 u to the 5th plus a c. So what was the u equal again? Oh yeah, the u was cosine of theta. So negative 3 to the 5th, 1/3 cosine of theta, all cubed. minus a 1/5 cosine of theta all to the 5th plus c. So now we're not quite done because we're not back to x's. So now it's triangle time. So what's triangle time? Triangle time is when we go back to the original substitution. So let's go way back up here. Here it is. There it is. So x equals 3 sine theta. X equals 3 sine theta. So I'm going to rewrite that as x over 3 is sine theta. Make a triangle. Here's your theta. Opposite over hypotenuse. The third leg here should be what you saw in your original problem. Oh, yes, I did see root 9 minus x squared, right? Yes, okay. So now it's my job to take and find cosine in this particular problem, what the cosine of the angle is. So here I'm going to carry along the -3 to the 5th. 1/3. Cosine would be adjacent over hypotenuse, and that's all to the 3rd power. Subtract off 1/5 adjacent over hypotenuse, all to the 5th power plus a c. Wow, that was a lot.